Good afternoon, class. We are looking at pre-calculus practice test, module 1 covering chapters 1 and 2, chapter 1 function, chapter 2 linear functions. And here's module 1, chapter 1 functions. It includes 3.1 complex numbers and 3.2 quadratic functions as well. So let me put this in slide mode. So the very first thing is we want to answer the following. Find the distance between the 2 points, -5, -6, and 4, 2. We also find the coordinates of the midpoint of the line segment that joins the two given points. Right, first and foremost, let me remind everyone about the formulas. In this case, if one pair has coordinates x sub 1, y sub 1, and the other one x sub 2, y sub 2, ultimately Pythagorean theorem results in the distance being the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared under the radical. So when we plug in the two pairs, we get 4 and 5, 9, squared is 81, 2 and 6, 8, squared is 64. When we add up 64 and 81, we get 145. So the answer is the square root of 145. This is the exact answer. And using a calculator and approximation with a bunch of decimals, however many decimals they ask us. For the midpoint, we add up the two pairs, the x coordinates and the y coordinates, and we divide by 2. And again, the proof is the fact that if you draw a line here and here, drop a perpendicular in the middle, the two triangles become similar triangles, and you can prove it that way. So let's add up the points as follows: -5 and 4, the x coordinates, divided by 2, -6 and 2, the y coordinates, add them up, divide by 2. So this becomes -1, so -1 over 2, and this becomes -4 divided by 2 is -2. So here's the answer for the distance. Here's the answer for the midpoint. Let's look at this word problem. Could you please read this question?
Yeah. A man drove 10 miles directly east from his home, made a left turn at an intersection, and then traveled 5 miles north to his place of work. A, if a road was made directly from his home to his place of work, what would its distance be to the nearest 1/10 of a mile? And B, if the road was made in the previous exercise, how much shorter would the man's one-way trip be every day?
Excellent. Thank you so much. So let's set up a drawing so it becomes clear as to what we are doing. So we are going this way, 10 miles. We are going up north, 5 miles. And according to Pythagorean theorem, a squared plus b squared is c squared. If this is a, this is b, this is c. A, B, C. This is Pythagorean theorem. Therefore, 10 squared and 5 squared, they add up. That gives us 100. That gives us 25. Therefore, c squared is 125, and c is the square root of that. And again, this is the exact answer. And then it gets approximated with a bunch of decimals. And so that's the answer for part A. As far as part B is concerned, if the road was made in the previous exercise, how much shorter would the man's one-way trip B. So this would be the straight line. So A plus B, subtract from it, this number would be the amount of distance that it will be shorter. So 10 and 5 minus square root of 125. I hope everybody understands the question and the answer. And of course, since they're asking for an approximation, I'm going to change this to 3.8 miles. Generally speaking, you want to carry out many decimals unless you are asked otherwise. In this case, we go with one decimal. This becomes like 11.2. Okay, 11.2, 15 minus 11.2 is about 3.8 miles. All right, the next question is, we want to solve this equation, which is a rational equation. There are a couple of things we need to know. Number one, the fastest and easiest way to solve a rational equation is to multiply by its LCD, the least common denominator. To do so, you have to make sure every denominator is factored out. So the first one and the second one are two linear statement. This one, we are going to factor it into x plus 1 times x minus 3 because we want two numbers. The product is -3, the sum is -2. And now two things happens. Number one, we're going to multiply by this LCD, x plus 1 times x minus 3, both sides of the equation. Number two, we exclude whatever makes each denominator 0, which is not an acceptable answer. So for example, in this case, x plus 1 can't be 0, so x can't be -1. In this case, x minus 3 can't be 0, so x can't be 3, which works the same way here. So we exclude those. We multiply it by this. And now if you multiply it by the very first fraction, everybody, x plus 1 cancels out. We get 5 times x minus 3. This case, x minus 3 cancels out, plus 1 times x plus 1. And the right side, both of them cancel out, we get -6. So all we have to do, distribute. Now we are going to distribute 5x minus 15 plus x plus 1, and the right side doesn't change. As you can see, these two add up to 6x. Minus 14, which we move it to the other side becomes plus 14 with -6, give us +8. Divide both sides by 6, we get 8/6 or 4/3, and we must check. We are fine. If there are, let's say, two solutions, one of them is -1, that's not acceptable, you cross it out, it's called an extraneous solution. All right, let's talk about lines and slopes and the interpretation. Slope is defined as rise over run, the average rate of change of y with respect to x. Just to refresh everyone's memory. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. As you can see, this has a positive slope. This has a negative slope. Horizontal line has slope which is 0. And a vertical line, the slope is undefined. So in the case of a horizontal line, HL short for horizontal line, the equation is y equals b. The slope is 0. The y-intercept takes place at 0b. I want to make sure everybody understands what I'm talking about by putting this point in general as 0b. It happened to be 0 to be here. So that's the y-intercept we are referring to. For the vertical line, x equals a. The slope is undefined. X-intercept in general located at a comma 0. Standard form of a line, ax plus by equals c. Slope intercept form, y equals mx plus b. Point slope, y minus y1 equals m times x minus x of 1. Two lines are parallel if they have equal slopes, different y-intercepts, and two lines are perpendicular if the slope of one is the negative reciprocal of the other one or the product is -1. So over here, x equals -2, y equals 3, we want to graph them. So we pinpoint the x-intercept, -2, 0, and it's a vertical line. We draw a vertical line here. In this case, we pinpoint the y-intercept because it's a horizontal line, 0, 3, and we draw a horizontal line. We want to find the equation of a line. Well, since they both have the same x coordinates, basically it's a vertical line, x equals 4, you really don't have to go through a process. Whereas in this case, both have the same y coordinates. Therefore, y equals -7. It's a horizontal line. Otherwise, you have to work it out. So as an example, we want to find the equation of a line in slope-intercept form that passes through these two pairs. Now we have to work it out, and I'm reminding everybody about what we just discussed. The very first thing is to find the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So -6 minus 10 over 5 minus -3. That's the slope. So the top is -16, the bottom is 5 plus 3, 8, and that gives us -2. We use y minus y1 equals m times x minus x of 1. So y minus, we use one of those pairs, either this one or that one makes no difference. So if you use this one, you get y minus 10, y minus 10 equals m, -2 times x minus -3 or plus 3. And if you use the second pair, it looks different, but ultimately when you solve for y and you put it in slope-intercept form, they become identical. Okay. So this one is -2x -6. We are going to move this, make it +10. And we end up with -2x plus 4. Before we move on, I want to highly recommend you check your work as follows. We use the first pair to come up with the equation. Now we use the second pair to check. If I plug in 5, -2 times 5 is -10 plus 4. Do I get the y coordinate? If I do, that means I haven't made a mistake in the process. Now, I can use both pairs to graph, but it's really a good idea to come up with the intercepts. Obviously, one of them is 0, 4. The second one is that, so when x is 0, find y, 0, 4, it's in the form of y equals mxb. And the next one is if you set y equal to 0 and solve for x, that becomes the x-intercept. So 0, 4 is the y-intercept, 2, 0 is the x-intercept. So 0, 4, 2, 0, connect them. Also, let's make sure we put both pairs that were given, and just to make sure we have it on those lines. You can always use the original pairs, but it's a good practice to go with the intercepts because they are more precise. We want to find the equation of a line that is perpendicular to this line and contains this pair or passes through that one. So the process is to find the slope first for the given line, and to find the slope, all you have to do, divide by 3. If I divide both sides by 3, y becomes 1/3 x minus 4/3, and the slope is 1/3 for the given line. The line we are interested in is perpendicular to it. Therefore, it's the negative reciprocal of that. So the one we need is the reciprocal of that 3, and then we negate that -3. So this is what we want. So we have the slope, we have the pair, we use those two with y minus y1 equals m times x minus x of 1 to come up with the equation of a line. To do so, y minus 1 equals -3 times x minus -2, which makes it +2. And therefore, over here we have -3x. Over here we have -6. We are going to move this and make it +1. And it gives us the equation of a line. As you can see, obviously 0, -5, 0, -5 is the y-intercept for this one. We also find the x-intercept to come up with the graph. So to do that, let's first finish this one because I like to do the setting. I like to do the setting class. So if we go back to this line, okay, obviously when we saw for y 0 minus 4/3, that's the y-intercept for this line. And if you set y equal to 0, this becomes 0, x becomes 4. So again, set this one equal to 0, x becomes 4. 4, 0, 0, -4/3. We pinpoint those pairs, we put them together, and that is the original line given. The line we want, in this case, 0 minus 5 is the y-intercept. And if you set this one equal to 0, x becomes -5/3. I assume everybody can see that. And we pinpoint those two pairs and draw a line. We also notice that -2, 1, okay, as expected, this line contains it. So that's how you come up with this setting. Now, one thing I want to make a point of, the concept of a perpendicular is that this makes a 90-degree angle. And if the x and y axis have identical scales, definitely this becomes 90 degrees. They are slightly different. That's why it may look different. It's important to know that. And again, making sure that -2, 1 is also there. Could somebody read this question, please?
Yeah. A retired woman has $50,000 to invest, but needs to make $6,000 a year from interest to meet certain living expenses. One bond investment pays 15% annual interest. The rest of it she wants to put in a CD that pays 7%. If we let X be the amount the woman invests in the 15% bond, how much will she be able to invest in the CD? B, set up and solve the equation for how much the woman should invest in each option to sustain a $6,000 annual return.
Excellent. Thank you so much. So we need to set up a table like this. By the way, this is a class of problem known as a mixture problem. In essence, similar to those where we add up different concentrations, because the total volume, in this case, total amount, stays constant. So let's plug in whatever is given to us. And again, that means the amount that is given to us for the 15% they want us to use X. Many times they don't mention that. We decide which one is X. It doesn't matter. So if this one is X and this one is 50,000, the total, right? The amount of interest, PRT, principal times rate times 10 years is $6,000. T is 1 when you're dealing with annual. This means T equals 1. All right. So why are we calling it a mixture problem? Because this total is constant. If this is X, it has to add up with something to be 50,000. And it's important to see that. Therefore, this becomes 50,000 minus X, not the other way around. If you add these two, X and minus X cancel each other, you get 50,000. If you're doing it with the system, we can call this Y. So this gives us the interest I equals PRT. Multiply these 2 times T is 1. So just 0.15X. These 2, 0.07 times 50,000 minus X. And the two they add up to $6,000. So when we get this far, practically we are done, because the most important part is being able to come up with that, and always a table helps us. So basically we keep this, we apply this to 7 times 5 is 35. You have 2 decimals, you have 4 zeros. 4 minus 2, that means 2 zeros, so 3,500 minus 0.07x, and we can see that these two combine into 0.08x. We're going to subtract 3,500 from both sides, we get 2,500. We divide both sides by 0.08, and it becomes $31,250, which means for 15%, we put this much, and the rest of it, 50,000 minus this number, which is 18,750 for the 7% return. By the way, sometimes, this question comes up, why not put all of it at 15%? There may be some issues like tax issues and things of that nature, or restrictions. That's Would somebody read this, please?
Flora starts riding her bike at 20 miles per hour. After a while, she slows down to 12 miles an hour and maintains that speed for the rest of the trip. The whole trip of 70 miles takes her 4.5 hours. For what distance did she travel at 20 miles per hour?
Excellent. Well, this is a class of problem known as motion problem. So we have D equals RT. D is the distance, R is the rate, the average rate or speed, T is the time. So we have to set up some sort of a table. We start after a while total. So we're going to start at 20 miles per hour. That's our speed or rate. So we put 20 miles per hour here. After a while, okay, we go to 12 miles per hour. So we put it here. So the whole trip is 70 miles. Here's the distance. The total distance is 70 miles. So just fill up the information as you come across it. Where does this go? The whole trip right here. And it takes 4.5 hours, the whole trip. So the time, total time goes here. So now, how much time did we spend at each case? By the way, we can figure it out. You can use any variable. It doesn't matter. For example, X, Y, Z. So if we use T here, representing the amount of time for the 20 miles per hour, and the total was 4.5. This must be 4.5 minus t. Again, pay attention to this. Make sure you write it properly, because if you wrote t minus 4.5 would be wrong. So the amount of distance is RT, this column times this column. So 20 times t for this one, 12 times 4.5 minus t for this one. And they must add up to give us total of 70 miles. This last column will give us the equation. 20 times t plus 12 times 4.5 minus t is equal to 7. So you keep this one, you're going to distribute this one. 12 times 4.5 is 54 minus 12t, and we combine these two into 8t. We subtract 54 from both sides, gives us 16 divided by 8. T is 2 hours. So if t is 2, and always in a case of an application, write the proper units. What was the distance covered here? 20t, or 2 times 20, 40 miles per hour. Needless to say, we can answer the rest of it as well, and it becomes clear. So for example, here we spend 2.5 hours times 12, and that gives us 30 miles. So everything should work out, and they do. Could somebody read this question, please?
First, solve the formula for W. P equals 2L plus 2W. Then use your result to find the width, W, of a rectangle whose length is 15 and whose perimeter is 58.
Perfect. So to do that, basically, you are moving things around. Since you want to solve for W, you're going to move the 2L to the left. So this is the width, this is the length. You're dealing with a rectangular shape, and P represents the perimeter, which is 2W plus 2L, or 2 times the parentheses W plus L. So we move that, and then we divide both sides by 2. Now, before we move on, I want to make a point, and that is, you can't cross those two, because 2 is not a common factor for the numerator. It's extremely important to know. Just because this has come up before, just in case, you could rewrite this, and you don't have to, as P over 2 minus 2L over 2, which is P over 2 minus L, but you can't drop the 2. So at this point, if you replace the L with 15, two times that is 30, subtracted from 58, you get 28. Divided by 2 is 14. If the units are given, you must always give it back with the units. If not, you don't have to. All right, we want to perform this, and I want to remind you of what we have learned regarding complex numbers. Complex numbers are in the form of a plus bi. That's a standard form. Square root of -1 is I. Square root of -n is I squared of n. A plus bi times a minus bi is a squared minus b squared I squared, which becomes a squared plus b squared. So let me just write this one more time. So this one is a squared minus b squared I squared, and I squared is -1, therefore the answer is a squared plus b squared. So when we want to multiply, we just do the FOIL. So this one gives you 2, this one gives you -3i, This one gives you minus 4i, and this one gives you plus 6i squared. However, what I was just mentioning, I by definition is square root of negative 1. If you square that, therefore I squared becomes negative 1. Now I cubed is the product of these two, which means minus 1 times I. And then I to the power of 4 is I squared squared. If you square this one, you get positive 1. So I to the power of 4 is 1. And therefore I squared, as I mentioned here, the same thing here. You replace it with negative 1, so this whole thing becomes minus 6. So 2 and minus 6, they add up to negative 4. These two add up to negative 7i, and we are done. If they said divide, put it in standard form, or rationalize, it all means the same thing. Because the denominator has 2 minus I, we're going to multiply by its conjugate or complex conjugate. Again, you remember this one. By the way, this comes, again, I want to remind you about something else. Everybody remembers a minus b times a plus b was a squared minus b squared, and that's what we have used here. Okay, so we are going to multiply by the complex conjugate of the denominator. So 2 plus I, we're going to multiply and divide by it, because this expression equals to 1. That is acceptable. When we do that, the bottom becomes simply a squared plus b squared. I showed that you can use that. So 2 squared plus 1 squared. The top, we're going to distribute 3 times 2 is 6, 3 times I, 4i times 2 is 8i, and this 2 is plus 4i squared. This can be replaced with negative 4, with 6, positive 2, this is 11i, and this is 4 and 1, 5. 4 and 1 is 5. Now, what I want to mention here, and it's extremely important, if you left it as that, there's nothing wrong with that. But the reason it's important to separate them, because if somebody asks you what is A, the answer is not 2, but 2 over 5. What is B? The answer is 11 over 5. All right, let me clean up the mess since I need this space. And here's the next one. First and foremost, square root of negative 9, okay, is 3i, plus 3 times square root of negative 16. 4i. So this is a basic product. This is 12i, and then the sum is 15i. All right, we can write this as 1 over I to the power of 6. And now there are different ways of handling it, but I'm going to show you the fastest way. Anytime you have powers of I, remember this is equal to 1. So divide that number by 4. And the quotient is not important. Whatever the remainder is, use that one. The remainder, when you divide 6 by 4, is 2. So it's 1 over I squared, and it becomes negative 1. What do I mean by that? Let me quickly show you another example. If I want to find this one, I divide this number by 4. Again, the quotient is not important. We know the remainder is 1. How do we know that? By the way, I hope you remember that a number is divisible by 4 if the last 2 digits would make it divisible by 4. So 24 is divisible by 4, therefore 25, the remainder is 1. So this is the same as I to the power of 1, which is I. Quickly, another example. What about I to the power of 43? I'm going to divide 43 by 4. And the remainder is 3. So therefore, I to the power of 43 is the same as I to the power of 3. and you know it's negative I. It's important to know this. There is really not much to it. All right, the square root property says that if x squared is a, where a is a real number, then x is plus minus the square root of a. So for example, if we have x squared equals 49, x is not just 7, it's plus minus 7. All right. Quadratic equation is in the form of ax squared plus bx plus c equals 0. You may have to complete this square to solve it. So how do we do that? A perfect square trinomial is a trinomial that can be expressed as the square of a binomial. For example, x squared minus 10x plus 25 is x minus 5 quantity squared. So how do we find this if it's missing? Notice that in every perfect square trinomial, the constant, in this case 25, is the square of 1/2 the coefficient of the x term, or b over 2a squared. In other words, divide this one by 2, square it, you get 25. That's the meaning of that. Therefore, if I want to go by that method, I make sure a is 0, a is 1 by dividing both sides by a if a is any number other than 1. For example, if it's 5, we divide both sides by 5. So therefore, when a becomes 1, we divide b by 2 and we square it. We add it to both sides, in which case the left side will always be x and b over 2, including the sign of that quantity squared. We add this one to the other side, simplify and solve by this method that was discussed. Of course, the quadratic formula x squared plus bx plus c normally is done by the quadratic formula x is minus b plus minus the square root of b squared minus 4ac over 2a. That's the method we normally use. And b squared minus 4ac is called the discriminant because it gives us tons of information. For example, if b squared minus 4ac is positive, we have two real solutions. The solutions will be irrational if the discriminant will be rational if the discriminant is a perfect square, and irrational otherwise. When that's the case, that means we could actually factor it. We didn't have to use that. B squared minus 4ac is 0. We have one real solution. If it's negative, we have no real solutions, or two complex solutions. We want to solve this by completing the square. So first and foremost, we move number 7. Here's b, number 6. Divided by 2 is 3. Square it becomes 9. So b over 2 and square it is 9. So we add 9 to both sides. Now, the left side, it is always the variable, whatever the variable, x, y, z, and then b over 2, including the sign. If it's positive, plus 3. If it's negative, negative 3. In this case, plus 3 squared. The right side is obviously 2. And now, the square root property says x plus 3 is plus minus the square root of 2. We move this, and it becomes minus 3 plus minus the square root of 2. Now, to do this, there are two things we need to do. We are going to move the negative 4, and we're going to divide everything by 2. When we divide everything by 2, this becomes z squared. This is minus 7/2, and this becomes 2. Now it's ready to be taken care of. B is negative 7/2. To divide a fraction by a whole number, you multiply the denominator by it. Since I want to divide this by 2, I'm going to multiply this one by 2, becomes minus 7/4. And 7/4, if I want to square it, becomes positive 49 over 16. So B is this, divided by 2. That means multiply the denominator by 2, square it. Now add both sides. Now again, what is the left side? You don't have to think about it. Whatever the variable is and whatever the b over 2. B over 2 happen to have a negative sign, so that's the left side. The right side, 2 is 32 over 16. Why 32 over 16? Because I see the denominator is 16. So the right side is 81 over 16. We take a root of both sides. Z minus 7/4 is plus minus square root of 81/16. As you know, 81/16 comes out to be 9/4. And we're going to add 7/4 to both sides. 7 and 9, 16/4 is 4. 7 minus 9 is negative 2/4. Negative 2/4 is negative 1/2. So there are two answers. Anytime you can combine and simplify, you must. We want to solve this by the quadratic formula. We bring everything to the same side first, and then we write down A is 2, B is 4, C is negative 5. We plug it into this. Minus B plus minus the square root of B squared minus 4AC/2A. So this is 6. This is 16. Minus minus plus 40 makes it 56. This one I can take the 4 is a perfect square, that's why. Times 14, 4 comes out as 2. And now I can factor the 2 from the top, negative 2 plus minus the square root of 14. So this cancels out. This one gives us 2. And here's your final answer. A is 7, B is 4, C is 3 in part B. Plug it again into the formula. And we need to simplify. -84. And so we have negative 68. And we can take the 4 out again, negative 68. It's 4 times 17. 4 comes out as 2, 17 remains, and a negative sign under the radical, we change it to I outside. It's important to notice this is outside. And sometimes they write this as a 2, in many texts they do, 2I squared of 17 to make sure I is out. And now you can factor the 2 out from the top, and the bottom becomes minus 2 plus minus the square root of 17I/7. All right, to solve this, we can multiply both sides by x squared. And so this becomes 2x squared, this becomes plus 4x, this becomes minus 1. Needless to say, x can't be 0. So we should write x can't be 0, because this says x can't be 0, this says x can't be 0, there we have it. And now we're going to know that A is 2, B is 4, C is negative 1, and we're going to plug into this. So we have 16 plus 8. So we have 24, and 24 is 4 times 6. 4 comes out as 2. And again, we have a common factor of 2 in the numerator. We drop it. And it's important to know, this is good enough, but we can't drop the 2's because 2 is not in common. So if you make up 2 fractions, this becomes minus 2/2, which is negative 1, and this remains. So you can't just drop the 2. We want to solve an absolute value equality, and here's the process. Number one, isolate the absolute value so that the equation is in the form of absolute value of ax plus b equals c. If c is less than 0, the equation has no solutions. So instead of 5, if I have, let's say, -5, right away, no solutions, done. However, if it's positive, and after it's been isolated, separated into two equations, ax plus b equals c, x plus b is minus c. In other words, drop the absolute value and say plus -5, and then move on and check. So in this case, because this is positive, we're going to drop the absolute value and put plus -5. Move the 7. Divide both sides by 4. It's important to know we can combine them, therefore we should continue. 7 and 5. 12 over 4 is 3. 7 minus 5. 2 over 4 is positive 1/2. So this is how you do the math. Now, you should always check with the original equation. So I'm going to use this space to check it, and I'm going to then erase it because I need this space. So for example, I'm going to check x equals 1/2. The checking takes place with the original equation, no in-between steps. Actually, I may have time or space here to do the 4 times 1/2 minus 7 in an absolute value. Is this equal to 5? So as you know, this is 2 minus 7. So this is absolute value of -5, and it's 5, and it does check with that. So it checks. I highly recommend you check the other one. We are going to move on. For the next one, we're going to move the +1. We're going to drop the absolute value and make it plus -2. We're going to move the 5. So we're going to divide by 2. 5 and 2, 7/2. 5 minus 2, 3/2. 2 answers. And again, when you want to check, you take it back into the original equation and check. I leave it for you to check it. Now, what about an inequality of absolute value of 2x plus 3 less than 7? The format is if the absolute value is less than a and a is positive, then x is between negative a and a, meaning it's sandwiched in between. So you drop the absolute value and sandwich it between negative and positive 7. We are going to move the 3, which means this. Divide by 2 every side. This is the inequality, and you're done. But if we want to write the interval format, this is how we write it. Interval format. Now we want to graph it on a number line. And on a number line, it's going to go from -5 to 2. So from -5 to 2, and you use parentheses, or you can put a hole here and here, and then try. Okay, so either way is fine. When the endpoints are not included, we use parentheses. When they are included, we use brackets. All right, what about this one? Remember, anytime you have an absolute value, equality or inequality makes no difference. The first step is isolation, so move the 10. So move the 10. So let's subtract 10 from both sides. And what happens when an absolute value is less than a negative number? There is no solution. Because this is negative, there is no solution. Why? Because it says less than. So if the absolute value is equal to a negative number, it has no solutions. If it's less than a negative number, it has no solutions. Remember that. Now, what if it's larger than? When it's larger, we first have to isolate. And then after isolation, then x is less than -a or larger than a. So what do we mean by that? First and foremost, let's move Let's move the 3, meaning subtract from both sides. Let's move the 2, that means let's divide both sides by 2. Now that is isolated, let me box that. I want to make sure this is extremely important. You can't touch it until it's absolutely isolated. Now we are going to follow this. X is less than minus a. That means drop the absolute value and say it's less than this number. Because it has the equality, we keep it less than -5 or larger than or equal to +5. So that's what they mean. Then we add 1. Then we divide by 3. And this is the inequality answer. X is less than or equal to -4/3, or X is larger than or equal to 2. Now, we want the interval notation. We write it in this fashion. Notice X is less than or equal to -4/3. That means minus infinity to -4/3. Negative and positive infinity, they always take parentheses because they are not numbers, they are concepts. -4/3 take a bracket because of the equality. Or that means union. X is larger than or equal to 2, 2 to infinity. Whereas the other one was and, the intersection of events. And if you were to graph it from -4/3 to the left, from +2 to the right, you can use bracket or you can use a solid point. You can, but don't use both. You could say over here, you put a point and you go to the right. So all right. Now the next one, again, you're going to isolate. It's similar to the previous example, but I want to show you the difference. The difference is this is greater than or equal to -6. When we say an absolute value is larger than or equal to any negative number, it's always the case because an absolute value in the worst case scenario is 0. Therefore, it's always true. Therefore, the answer is all real numbers minus to positive infinity. It's important to know that. All right, we want to solve this one and we follow the same format. We are going to move the 7. That means we want to isolate this square root. We're going to raise both sides to the second power because this is a square root. We want to take it out. This comes out. This becomes x squared minus 2 times x times 7 minus 14x, and then 49. Again, I hope everybody remembers a minus b squared is a squared minus 2ab plus b squared. If it's a plus, it's a plus here. And so that's what we have, and we are going to bring everything to the same side and factor. So we are going to subtract 2x, and we're going to subtract 1, and we end up with the following: x squared minus 16x plus 48. We are going to factor this, which means we want 2 numbers. The product is 48, the sum is -16, and we end up with x minus 4 and x minus 12. There are 2 answers. X is either 4 or 12. Must check, we must check. And here's the reason, especially when you raise it to a power which is an even power. In the process, we may introduce something called an extraneous solution. So let's plug in 4 into the original one. 2 times 4, 8 plus 1, 9, square root of that. This is 3. Is 3 plus 7 equals 4? No, that doesn't work. Let's plug in number 12. 2 times 12, 24 and 1 is 25. So this is 25. And the square root of 25 is 5. Is 5 plus 7 equal to 12? Yes, it checks. And this is the correct answer. All right, I want to solve this, and we are going to raise this to the power of 2 and combine them. So this becomes x squared plus 4x plus 4, and this one becomes x squared, then minus x and minus 6x is minus 7x plus 6. I'm assuming nobody has any problem with the foiling. X squared cancels out the x squared. This becomes 11x. This becomes 2 divided by 11, and you're done. All right, we want to solve this, and the best course of action is to undo the exponent. Remember, in this case, it's an exponent that to the power of 5/3, that means the cube root. So we're going to raise it to the power that is the reciprocal of this number, which is 3/5, both sides. So what happens is that these two undo each other, and the left side comes out as 4x plus 1, and the right side is 32 to the power of 3/5. And I remind you that a to the power of m over n is the nth root of a to the power of m, or the nth root of a to the power of m. So this one would be the 5th root of 32, which is 2 to the power of 3, which makes it 8. And now, of course, I'm going to subtract 1. I get 7 divided by 4 is the final answer. So we are going to move on. We want to solve this, and we can distribute and do the math. That means raise this to the power of 2, combine them, and so forth. But since both of them are 3x minus 4, using a substitution method is faster and easier. So we let 3x minus 4 be something such as y, any variable except x. So now this is 2y squared plus y minus 1. And this is an easy factor because 2 is a prime number, so you recognize it as y plus 1 times 2y minus 1 equals 0. So y is either negative 1 or positive 1/2. Now, have we solved for x yet? No. So you go back to this one and set them equal to those two numbers. You move the 4 and you divide by 3. So therefore, we are going to add 4 here, becomes 3 divided by 3 is 1. We're going to add 4 becomes 9/2, divide by 3 becomes 3/2. So, and you can always check with the original equation. In the next case, again, substitution will do the job. We let x to the power of 1/3 be m. So this really becomes m squared. Move everything to the left and do the factoring. We want two numbers. The product is -3. The sum is -2. M is either 3 or -1. So it's important to know if x to the power of 1/3 is m, then if I raise this to the power of 3 becomes x. So, and this one becomes x cubed. So we raise both sides. To the power of 3. So if x is m cubed, x is m cubed, 3 cubed is 27, minus 1 cubed is -1. You can always check with the original equation. All right, in this case, we move the -15, and you can do by substitution, or you may notice that since this is of degree 4, this is of degree 2 and 0, you can just do it in one shot. You want two numbers, the product is 15, the sum is -8, you can do it that way. Or if you want to do it by the substitution, everybody, you can let r squared be, for example, x, then this becomes x squared minus 8x. Let's just put it here, x squared minus 8x plus 15 equal to 0 and factored. But you can do it just the way it is, and r squared is 3 or 5, and that means r is plus minus square root of 3 plus minus square root of 5. For part B, we have two choices. We can multiply both sides by b squared, or just we go by the substitution and we let b to the power of negative 1 be x, in which case this becomes x squared. And this is really not too bad. Again, I'm hoping everybody remembers factoring. We will discuss that later on also. But anyways, the reason it's not a big deal because 1, you have to go with 1 and 1 or negative 1 and 1. So 6 is 2 or 3 or 1 and 6. When you do the math, x becomes either 1/2 or 1/3. And it's important to know b to the power of minus 1 equals x. That means 1 over b equals x. That means x and b are reciprocal of each other. So the reciprocal of 1/2 is 2, the reciprocal of 1/3 is 3, and those are the answers for B. Could somebody read this question, please?
A fitness club charges $20 a month as a monthly access fee and $2 per day of use. A, express the monthly cost to C in terms of daily usage. B, what will the monthly cost be if the club is used 15 days this month?
Excellent. So if we let X represent the number of days, we have a fixed cost of 20 and a variable cost of 2. This is the slope in essence. This is the y-intercept or the c-intercept. So we're going to write c of x is 2x plus 20. And if we want to know what happens in 15 days, we replace the x with 15. 2 times 15 is 30 and 20. They're going to charge us $50 for this case. If the length of a rectangle is twice its width and its perimeter is 90 meters, we want to find the dimensions of the room. So here's the width, here's the length, and the length is 2 times the width. And we know the perimeter has the formula 2 times L plus W or 2L plus 2W. And that is given as 90. So all we have to do, replace the L with 2W. So if I replace the L with 2W, this becomes 2 times 2W or 4W, which makes it 6W equals 90. And all I have to do, divide by 6. The width becomes 15, and pay attention to the units, meters, and the length is double the size, therefore is 30 meters.